First thing we always do is x-intercepts. How do you find the x-intercepts? Set it equal to 0. It's like setting the y to 0. And we've talked about several times, what's the shortcut to that? Right, it's really just when the top is 0. So you can just work from that point. Now, what would I have to do with this top? Slip and slide. So why don't we just come up here and we'll factor and then we'll come down and finish this. So if I slip and slide up here, it gives me x squared minus 5x plus 4. So that would factor into what? And then what do we do? Okay, when we do that, we get x minus 2 and 2x minus 1. On the bottom, x squared minus 4. What can you do there? So a lot of times I would have you factor before we actually found all the information. So that's what I'm doing right here. What do you notice? So my factored form is 2x minus 1 over x plus 2. That is actually all I need to look at when I'm deciding my asymptotes and x-intercepts and all of that. But when something cancels, what does it create on our graph? A hole. And we need to know where that is going to occur. So you look at the thing that canceled. What makes x minus 2 equal 0? Positive 2. Then to find the y value, you plug 2 into what's left. So I got my 2 from the fraction, or the factor that canceled. If I plug 2 in here, I get 4 minus 1 is 3 over 4. So 2 3/4 is a hole on my graph. We graph that, that's just an open circle. At positive 2, positive 3/4. So we've talked about finding a hole before, but this is the first one we've actually seen happen on our graph. Does everyone understand how I got that point? So anytime something cancels, you have a hole. The x value is from the factor that canceled. To get y, you plug your x into the fraction that's left. And so now when I'm trying to decide x-intercept, we've said it's really just when the top is 0, and my top is now just 2x minus 1. So if you set that equal to 0, we get, so I hit the x-axis at 1/2. How do you find a y-intercept? Put 0 in for x. You can do the original, we can do our reduced one. I'm just going to go with this reduced one. If my x is 0, then I get negative 1 over positive 2. So I hit my y-axis at negative 1/2. Vertical asymptote. It comes from the denominator. So to find a vertical, you are looking at what makes the denominator 0. And what would that be? Negative 2. And you have to write x equals negative 2. Because it's a vertical line, it's an actual line, so we need an equation. And we draw that as a dashed line. Okay, then we have to decide horizontal or oblique. And the way we've done that is by dividing our highest powers of x. Now, if your x on top is 1 bigger, what kind of asymptote do we always end up with? Oblique. And then you have to go do the whole long division to get it. When I'm dividing these, it doesn't matter if you do the reduced or the original. What is 2x squared divided by 1x squared? 2. So that is a horizontal y equals 2. Right, how many pieces will this graph have? 2. One on each side of my vertical asymptote, something to the left and something to the right. The right-hand side we actually already can tell. It has to go through all of these points. Your open circle is on there, but make sure when you draw your curve you don't accidentally fill it in. So we know we have to draw something that's curved and getting closer to our asymptotes. So this section is going to look something like that. All right, over here we have two options. It could either be above that horizontal or below. How do we figure out which one it is? Plug in. All right, we put -3. You can go with the original or the reduced. I'll just go with my reduced. If I put in -3, -6 minus 1 is -7 divided by -1 is 7. Now, I don't care if you plot that exactly, but what that tells me is it's bigger than 2. So I know this section has to be up here. So my graph is going to look like this. What questions do you guys have on this? Why don't you guys start this one? Try to list off as much of the information as you can. Intercepts. To find intercepts and asymptotes, factoring helps. So I would always recommend starting by factoring. So the top would be +4 and -3. The bottom -3 +2. And what do we see? The x minus 3 cancels. So this reduces to x plus 4 over x plus 2. When something cancels, that means there is a hole or an open circle in the graph. And we have to be able to give the point where it happens. So the x value comes from that thing that canceled. If you set x minus 3 equal to 0, what do you get? +3. So that's where I get the x value. To get the y, you plug 3 into what's left. So we get 7/5. Okay, so we plot that as an open circle on the graph. +3, 7/5, it's like 1.4. Nice strong open circle with it. Now we go through the rest of our stuff. So the x-intercept. An x-intercept is where you hit the x-axis, so y is 0. We have talked and said that in a fraction that really just means the numerator is 0. So if you set the top of our reduced fraction equal to 0, we get -4. To find a y-intercept, that's when x is 0. So if I put in 0 for all my x's in my reduced fraction, we get 4 divided by 2, which is 2. Vertical asymptotes, where do we look for that? The bottom. What makes the bottom 0? -2, and it is a line, so you have to write it as a line. X equals -2. Okay, now we decide horizontal or oblique. So to do that, we divide the highest powers of x. You can do it here, 1x divided by 1x, or back here, x squared divided by x squared. What do we get either way? 1. So if it's just a number, that's a horizontal line, y equals 1. Okay, then we do test points as needed. Do I actually need test points on this one? No. We know we have two sections, one on each side of the vertical, and we have to decide if they're above or below the horizontal, but I can tell this one is above. Make sure when you're drawing it, it's curved, getting closer to your asymptote. Don't accidentally fill in your open circle when you graph it. So it looks like this. Over here, I already have a point, so I can tell it's below. So this section will look like that. How are we doing with these? Do we need another example? Okay, let's go ahead and look at one more. Hold on, I might change this problem. Okay, for a second. We haven't done. Do we need one with an oblique as a review today? All right, let me change this problem so we have something with no oblique since I haven't. So just go down to the bottom of your paper. I think you have some extra room there. Let's say I gave you this. All right, so first step is factoring. Top would factor into positive 5 and negative 1. Bottom, we can't do anything. So nothing cancels, so that means this one does not have a hole in the graph. Where do we look to find the x-intercepts? The top. What makes x plus 5 equal 0? And what makes x minus 1 equal 0? So I know 2 places I'm going to hit my x-axis. Okay. How do we find a y-intercept? 0 for the x's. Doesn't matter if you do the factor to the original. Not a bit. If I just go with the original, I have 0 plus 0 minus 5, so negative 5, over 0 plus 3 is 3. So I hit the y-axis at negative 5/3. How do we do vertical asymptotes? We get x equals negative. Okay, horizontal or oblique, it's one or the other. We decide by dividing. We look at those highest powers of x. When you take 1x squared divided by 1x, we still have an x in it. If there's still an x, that means it's oblique. Oblique is a normal line, y equals mx plus b, so we have to divide to find it. So the numerator goes inside, denominator goes outside. So we begin by dividing the first terms. What is x squared divided by x? X. Then you multiply. You take x times the x plus 3. So that's x squared plus 3x. Then what do we have to do? We need to subtract it off, so we usually just change all of our signs and then we can see positive and negative x squared cancel. 4x minus 3x is just 1x minus 5. And now we're back to the beginning. You divide. What is x divided by x? 1. That's all I need. So my oblique is y equals x plus 1. So to graph that, that is a line, y-intercept of positive 1, slope is 1, so up 1 over 1. So it looks like this. I have to have two sections, one on each side of my vertical. It's either going to be above this oblique or below it. Do we know right now which one it is? I think we should. How can I tell? I already have a point, don't I? I already said this is going to hit the x-axis, so if you're going to go through that point, that means it's above. If you didn't have it, that's when we plugged in points to tell. We have this section. Now we need to go to the other side. So, my options, I can either have a graph up here or a graph down here. How do I know which one it is? The points that we have. We already know our x and y intercept. They're down here, so this one's going to be down here. Okay, so sometimes you have enough points given to you to draw the graph. Other times you have to plug in numbers to see. But you have to have points on each side of your vertical asymptote. So if we only have one vertical asymptote, our graph has two sections. If we get two vertical, that breaks it again, so we get three sections of our graph. So, the rest of the time I want you to work on that handout, the day 3 handout. It is due tomorrow, so you should be working on those. If you are having trouble, you need to get on my advisory list for today.